The telemax EVO PLUS is the largest and most powerful UGV in the telemax product line. Weighing in at under 300 pounds, an economical footprint, and up to 15 hours of runtime, the telemax EVO PLUS is multi-mission capable, providing a range of operational needs for EOD, CBRN, and tactical, from vehicle and package inspection to environmental mapping. Getting to those mission-critical areas of operation, the EVO Plus's versatile 4-track drive system with articulating tracks allows it to navigate virtually any terrain, easily climbing stairs and traversing gaps up to 16 inches. All tracks can be controlled together, as pairs, or individually, allowing the operator full control of the orientation of the robot to help in navigating uneven terrain. Additionally, an onboard auto-leveling feature is integrated into the robots, allowing it to sense the environment underneath it and stabilize itself on uneven terrain. Heavy lift capable and outfitted with an 8-inch gripper, with a lift capacity up to 176 pounds and a reach of 60 inches, the telemax EVO Plus's manipulator is capable of reaching over, under, and into complex environments. Key to the EVO Plus is its 6-degree of freedom manipulator, featuring tool center point control. This offers maximum flexibility and freedom of the manipulator to complete tasks such as a 360-degree inspection of an object without moving the UGV. Tool center point control allows for complex manipulation through simplified user inputs. This is a software-based system that coordinates the movement of all rotational joints of the manipulator, allowing the operator to simply focus on a target, choose their direction and speed, and move directly into that target like a human arm would. The system knows where everything is at any time on it, including camera systems and accessories, allowing the operator to focus on the task, not worrying about where the arm is in space as it's manipulating. In addition, proprietary collision avoidance protects the system from accidental damage through unintentional user inputs. Every telemax UGV features 32 pre-programmed modes for both the manipulator and the track systems. These easily executed modes help to provide the operator with consistency in their execution, reducing the cognitive load on the operator and increasing mission success. A great example of this is our proprietary automatic onboard tool exchange. Like all other telemax UGVs, the EVO Plus is equipped with 2 modular tool reservoirs on the side of the platform, allowing us to store things like inspection cameras, window breakers, disruptors, chemical and biological sensors, and powered cutters. The operator simply selects that they'd like to pick up one of these tools. The robot takes over, picks up the tool, utilizes it in the gripper, and then when the operator is done with the equipment, they simply tell it to return back to the tool magazine. This allows the operator to change their concept downrange and which tools that they would need, reducing the overall time of back and forth for the load out of the mission. All of the telemax and Theodore robots operate off of our Robo Command Common Architecture controller. This provides a multi-touch, intuitive touchscreen control with ergonomically designed joysticks, and features the ability to create a secure wide area network communication system through our IP Mesh radios. The sensors are becoming smaller, lighter weight, lower power requirements, so we can fit them into more places on the equipment than we could previously. So with the lower demand for power, we can put them on the end effector of the tool. We can actually put them into tools, and it basically allows us higher resolution, which gives us more ability to see detail of objects. And with artificial intelligence and machine learning, we can actually then make decisions based on that increased perception of the data. The mapping capability on the robot themselves uses 2D and 3D scanning LiDAR. What it does is maps the building, but then also overlays an RGB or color image over the top, giving a photorealistic environment. So operators have the ability to actually come down into the environment and now move around it and see it in 3 dimensions in a virtual environment, and understand, where different obstacles are. You can actually see pictures on the wall. You could see a backpack or a threat and start to identify some of those areas. But then through augmented reality, we can actually utilize the ability in a completely pitch black environment to see depth, and allowing the operator to then understand where obstacles are, along with navigation systems that help to identify those and navigate around particular obstacles that maybe an operator didn't see. And so the fidelity of these sensors and the more scans that we can get of an environment gives a better picture of what obstacles and threats may arise.